Hey guys, welcome back. Fred Kynes with all kinds of classics. And in this episode, episode 25, we continue on the Valley Pan and integrating, creating, if you will, the oil fill tube now to press fit into the Valley Pan for the 331 Hemi. This is a 1953 331 Hemi. And again, we're moving forward with what is going to wind up being a very unique engine, I think, in the sense of how it's going to be fed fuel and air, and how we have to get everything to kind of work around the new stuff that's coming for it. But at this point, we're building the fill tube. I'm going to show you some of the lathe work that I did to create a fill tube out of a piece of aluminum tubing. Now, yep, I didn't use the stainless like in the last video, and how we proceed forward to finish up this portion of the project. Still waiting for parts for the chassis, and I talk a little bit about that. But share, like, subscribe, and keep the comments coming. Love the comments. Thanks, guys. See you soon. Morning, everybody. Let me turn the TV down. Okay, so if you remember from the last few videos, I took this piece of stainless, I turned it down for a press fit into here. And then I was going to come up with a solution for a cap there. I do like the height, 5 inches. I like that. I think it looks pretty. I think it works well. The valve covers are going to sit up about half the distance up on the cylinder heads. There's going to be clearance, you know, all that preview and investigation's been done. I'm not totally ecstatic about this. I don't care that the router left a little mark there because I want to fill this probably with epoxy. I've got some 400 degree epoxy that I can get a very nice registration, a very nice set of letters. But it's hard to see. But like this loop here, you can see there's a little bit of a step and a lip there. And so I want to get do some body work on this. I can either paint that or I can powder coat it. If I powder coat it, I can get conductive filler material that will withstand the heat. It's designed for that. Believe it or not, in today's world, you can do almost anything. And I can get a little container of that, and I can fix and dress and file that and straighten it out. But I want that perfect, and it's not perfect. So at the end of the story, this is all going to get painted. I'm not a huge fan of chrome. I like chrome, but I don't like it all over the place. I don't want that 1970s, 1980s look. So I did purchase online a length of aluminum tubing. I just cut it. I did turn this. This isn't for pressing into the manifold. This is for pressing a flange onto this. The OD of this flange is way too big. And I'm going to go with a OEM, in this case a Ford OEM engine oil fill. I like the yellow lettering. I like the yellow call-outs to all the maintenance items on the vehicle. I think it looks cool. This is a rubber seal right here. And so I want to cut a flange, probably the diameter across my fingers, right? On this. This will screw into here. I will cut this OD. I will weld this on. I will finish it. I will cut the OD. And then turn this end down so that it presses into the manifold. It's the same length of that piece that I got, so that it fits into the manifold. Now I just cut this off with a cut-off wheel. I didn't part it in the lathe or any of that. That's the fastest way to get this done, because no matter what, I have to dress the end of this and turn this down for the press fit. At this point, I'll probably get this squared and then come back and turn it on the lathe. Now I've set my lathe up, my gearing up to cut 8 threads per inch. This is 8 threads per inch. I did a quick test on the end, and certainly it's probably hard to see, but it does register properly for 8 threads per inch. So now I need to just go and do some inside turning on this to cut those threads and go back and forth and test it on there. So that's where I'm at. This is at the raw stage. I did turn this end, that's it, cut this off, and I'm gonna get started on the project of turning that on my old 1926 South Bend, I don't remember the year, 26, 27, 28 South Bend lathe, 9-inch lathe. I just got to thinking, there's probably a ton that don't really even know how to cut threads on a lathe. And so I figured I'd do a little video on it. So there's several gear sets that you can change on this side. And so I'm driving off of here. This is a 24 tooth gear. And this is a 24th tooth gear. And this lathe, the base is 8 threads per inch. So if I went to a 48 tooth gear here, this gear is unchangeable. This is the shaft that goes through. Then I'd be cutting, I'm at 8, I'd be cutting 16 threads per inch. All this, of course, is just a means of getting the gear and the rotation to the same, transferring the power from here to here. But if I pull this out, I can swing this up and turn this screw a different direction. But the reality is it's these two gears that establish the ratio, the drive and the driven. Everything else in the middle is just a means of getting the power to there. I hope that makes sense. On this particular lathe, I drive, it's a 6-speed, so I drive at these 3 speeds normally for cutting. I pull this pin which disengages the headstock from this, and I engage this gear with some finesse there, like that, which takes the power from this to a solid gear in here to turn this gear, which is larger, to that smaller gear, to this larger gear, which is connected to the headstock. But I'm disengaged from this, so I'm reducing the turning speed. The lathe goes reverse or forward. I got my thread cutting rig on my headstock. This engages the tailstock to move at a fixed rate. Driving this in and out, or in. If I go this way, it'll drive it out through that gear reduction, through all of this gear reduction, okay? Now, if I were to take that down and disengage that, I would, and accidentally turn it on, I would lose my position. So this must stay engaged, which means that I can't go into here and rotate this piece or change anything within the setup at all. I can only operate that switch right there, moving this in and out along that line at that rotation travel speed relative to that rotation speed until I'm done cutting thread. It's confusing as hell, but you just keep running your passes in and out. So to get to the end, you need to overcut on a lathe. On this type of lathe, you need to overcut your thread. I have no indicator, rotational indicator that tells me that I need to start at the same number or anything like that. It's a very old lathe. And so some of you might say, well, all you got to do is look at your dial, engage at 2 or 4 or 6 or 8 or 0 on the dial, and you will forever be in the same position. And all that means is there's a dial that rotates there that if you engage this at position 2 on the dial, you always engage at position 2, and then your relative position up here will be the same for cutting threads. I don't have that, so I can only start and stop. And because I am rotating, because the tube is coming down here, that's the cut is on the top side of this, that I need to drive it out, cutting, shut off the lathe, reverse it, drive it in, scraping, not cutting because I'm coming up the top side of this tooth, and then drive it out and slowly index this out, apply pressure to cut. So I have to take multiple passes as I'm going to keep the cutting going. It doesn't provide perfect threads. I mean, they're very, very good threads, and there's no cleanup or anything going on at this point. But I'm just driving this in and driving it out. So we'll run it in. I haven't done anything. And we've got a little depth here because I'm test fitting the cap, kind of going back and forth. But we can see that's moving as long as I'm in right now in reverse. Going in, and I stop because let's go like this, because I'm in with the cut near the end. That's about all I can do. I could put a mark on here. I've done that before. I made a stop right here. But what I found for something like this, it doesn't matter that the threads taper a little at the end. I just need to grab what? 1, 2, 3, 4, 5 threads total if I keep this one. And we can clearly see in here that I've captured a lot more than 5. 1, 2, 3, 4, 5, 6, 7, 8, probably 9. So, and at this point, then I just reverse the rotation, or go forward, and I'm cutting. I didn't index it more, but I got a little material on that pass, and you just keep going and going and going. I can't disengage this and roll that wheel. I have to drive the headstock back to give me enough clearance to do a test on the cap. So there you have it. Cutting threads on a lathe from the 20s. All right then, here we go. We've got threads, 8 threads per inch. You can see I've test fit this a few times. It's been tight, but now there we go, just a little bit. There we have it. Phase 1 is complete, and now is the moment that I don't F up the threads as I get this flange put on here. I'm going to open this flange to a decent fit to this. Weld it on. I don't know, maybe I should step it just a little bit. Then weld it on, burn it in, taper the shit out of this. Weld it on this edge and then just face this edge, because that's where the threads start. And I went plenty deep, plenty deep. So there we have it. Beginning phase 2. All right. So what I've done is I've turned this step down. It's threaded in here. I found a washer that I could use to protect the threads. This is the fill side. I cut, tapered rather not tapered, I turned this down to a press fit for the intake manifold. And then I came in and cleaned up this hole to the exact ID of this. I just took my pencil Dremel with a burr and put a chamfer on this. So this is the top side. Got my threads protected. I don't, you know, if I need to turn and clean up the threads, I'm only cleaning up the exterior side of the threads. So now I've developed a channel all the way around to which I will begin welding all the way around there, and then I'll turn it. But I should have enough material, about half the disc, about 1/8 of an inch down on this 1/4 inch piece. Yeah, here, I'll show you. Oh, maybe 100 thou down on that piece. And so I will begin welding this. This is always the scariest part because you don't want to up the threads, but I certainly won't get any weld in the threads. This isn't tight, it's just, you know, snug, but I want to keep it from moving, and if I get a little deformation here, I'll be turning it anyway. So that's where we're at, sitting in soft jaws. I'll hook my ground to the bottom of the tube, and I'll slowly tack this all the way around, enough to have a build so that I can face this whole edge. And then I will turn this down to the appropriate diameter, and voila, there we have it. So, making progress. Okay, here's the first stab at it. Again, I stayed off of, it's cooled down a little bit. It's amazing how quickly aluminum cools. So I focused my energy onto the 1/4 inch material, not on the tube. So probably a little more like this kind of an angle versus this kind of an angle. And I got in, and I, you know, the washer, we built up over the washer, but I just wanted continuous, it still is a little hot, continuous speed. So now I'm going to come in with the flapper or a cutoff wheel and remove material on top of the washer and just continue to inspect the weld as I go. If I need to touch it up, I'll touch it up. Basically get it to the point where I can chuck it up in the lathe. So that's just a MIG, 120 volt MIG welder. I actually popped a circuit doing this with argon and a spool gun. So thanks. Okay, here we go. Basically what I did was ground down the weld, tested, ground. I used the cutoff wheel to get, you know, because I had a lot of balls and bubbles on there, and came over with the flapper and just, you know, I didn't bear down on it, but I took quite a bit of material and even thinned the washer. Okay, washer sitting in there, and grabbed a screwdriver. Didn't want to bung up the thread, so just got under there and popped that guy out of there. And you can see now the integrity of the threads. Clearly I can see now too that I need to polish those threads, but nothing's happened on those yet. And that's all, you know, brass wire brush. But then I had some blow through there. That would be the thinner spot. But now, of course, I'll chuck this back up on the lathe, center it. This will get properly tapered, faced, and trimmed. So that's the phase we're at right now. Everything is moving along perfectly so far. I'm sorry about the background noise, but we got it. I cut you can see the rounded edge. for the seal. So I cut that into there, parted this off, oil filter in. There you go. Seals up beautifully. Good to go. Moving on to the next thing. Well, there you have it. I mounted the thermostat housing. Those two AN fittings will then go out to the cylinder heads. Oil fill, I pressed it in. A good press fit, and I used Loctite, pressed it in. Sits down there good. You know, I got that off of eBay, and look at the paint already flaking off of it. Look at that. What a joke. So I'll have to basically go to the salvage yard, get one off of a Ford, an OEM one, because for crying out loud, it's gonna at least last longer than that. That's upsetting. But there you have it. There you have it. Getting all the details out of the way. Should be interesting to see how this runner fits in behind here, but he's gonna miss. He's gonna miss. I'll make sure he misses, of course. But wow, it's coming along.